Alright guys, I know you were expecting a quiz over just linear functions yesterday, but I was unexpectedly ill. So the quiz that you got was really one that was supposed to be last 6 weeks. It was over mainly quadratics. And we will talk about that. Yes, there were some tricky ones, I agree. But most of it I thought was okay. There was maybe one or two I felt a little bad about. Okay, let's focus on what's happening right now. Right now, you should be able to do these 3 questions. Yes, there is a trick to 1 or 2 of them. So please listen, because this could show up on your next quiz. I think instead of doing a new lesson tomorrow, we'll take the quiz I meant to give you. So the quiz I meant to give you was just over lines. And the main thing you should be able to do right now is find the equation of a line when I give you a point and a slope. Or when I give you 2 points. Okay, and you should also be good at going from one form to another and knowing about parallel and perpendicular lines. So all of that could be on the quiz tomorrow. Now, look at number 1. Number 1 is about parallel lines. What can you tell me about parallel lines? They don't intersect. They have the same slope but different y-intercepts. So what I am really doing on number 1 is I am giving you a point and a slope, but I'm doing it in a tricky way. First of all, I didn't come out and tell you the slope. I told you to be parallel to this guy right here. So that means you had to know that this slope is 2, and that parallel lines have the same slope, so you had to know, hey, I'm supposed to use the slope of 2. I don't need the 5. And I gave you a point, but I gave you a point in a tricky way. If I gave you the x-intercept of this line is -3, that means it is crossing the x-axis at -3. What point is that? -3, 0. So you had to kind of know some things about intercepts and parallel lines before you could do this problem. So now I know a point and a slope. What's the only thing I'm missing? The b. You've got to find your y-intercept that matches this description. That's where you plug everything into y equals mx plus b. I used the y value from my point, which you had to know was 0. I used the slope from this line. You had to know parallel lines have the same slope. My x value was -3 plus b. Y equals m times x plus b. 0 equals -6 plus b. What's my b value? 6. I've got to add 6 to both sides. So what's my equation? Y equals 2x plus 6. Let's check a couple of things. Is it parallel to the one I gave you to be parallel to? Yes, it's got the same slope. Does the point -3, 0 land on the line? Well, let's see. I'm going to go to zoom 6. Y equals, my answer was 2x plus 6. And the point that I gave you was I told you it had an x-intercept of -3. That means the point -3, 0. And it sure looks like it's there to me. Let me just double check. Sure enough, look, -3, 0. So I gave you that point, and I told you to be parallel to y equals 2x plus 5. Just to make sure, I'm going to put in the line I told you to be parallel to. Parallel lines do look parallel on your calculator screen. Remember, perpendicular lines don't really look perpendicular. Yeah, they're super close. Their y-intercepts were just one space apart. Turn what into a fraction? Yeah, now you don't turn it into a fraction. On perpendicular lines, whatever the slope is, you flip it upside down and change the sign. But this was not a perpendicular question. This was a parallel question. Parallel questions have the same exact slope. And they should look parallel when you graph them. And they do. They're super, super close together. Okay, now, number 2. Number 2 was just giving you 2 points. If I give you 2 points, that's really kind of easy, because what can you do if you know 2 points? Stat edit, stat calculate. The trick here was knowing about intercepts, and we're going to talk about them in detail today. If the x-intercept is 3, picture that. That's 3, 0. If the y-intercept is 5, that's not 5, 0. That's 0, 5. Okay, so I'm giving you 2 points in a tricky way. You had to know about what intercepts mean. And if you need to draw it out, draw it out. Some kids forget where the 0 goes. Okay, and then once I know my 2 points, I could just go to Stat Edit and put those in there. There's 3, 0. And there's 0, 5. So I can give you 2 points lots of ways. I can give it to you just by telling you the 2 points. I can give it to you from a picture. Or I can give it to you like I did here, telling you about intercepts, because that's as good as telling you a point. And once I know my 2 points, I go to Stat, Edit, put them in there. Then what? Stat, Calculate, and this is all about lines. We're doing lines right now. Plus, let me just tell you guys, 2 points is never enough to find any kind of other equation. This has got to be linear. And then look what it tells me. Sure enough, my y-intercept is 5, which I already told you that. My slope is a yucky repeater. What can I do to figure out the fraction? Yeah, negative 1 point, whole bunch of 6's, and then math, enter, enter. And that will tell me the fraction. So this equation would be y equals negative 5/3 x plus 5. It told me the y-intercept was 5, which I already knew that because that's one of the pieces of information I told you. Right, Ramiro? You got that one? Good. All right, now number 3. Ashley, here's that perpendicular line you were talking about. This could show up on tomorrow's quiz. So Julio, if I am telling you to be perpendicular to this line, then I am telling you a slope in a very tricky way. What is the slope of this line? Of this line? Negative 1/2. So if I want to be perpendicular to it, then what slope should I use? 2. So I told you what slope to use, but I did it in a tricky way. And I told you a point, and I also told you the point in a tricky way. If the x-intercept is 6, what point am I telling you? 6, 0. So I gave you a point and a slope. Do the math if you haven't already. You've got to know how to do this for tomorrow. The calculator can't do this for you. You've got to find the b mathematically. It can check it for you. But this is where you have to plug in stuff to y equals mx plus b. And it shouldn't be that hard because the y number is a 0. The m number is a nice whole number. What's my y-intercept? Negative 12. I got to move that 12 to the other side. So this equation would be y equals 2x minus 12. Now I would always encourage you to check your answer. There's usually at least one thing you could check. The one thing I could check here is that my answer better have the x-intercept of 6 on it. So I'm going to put in y equals 2x minus 12. I'm going to look at it. Does that look like an x-intercept of 6? And just to verify, I would look at my table of values. And I'm looking for the point 6, 0. Of course, you had to know that an x-intercept of 6 means 6, 0. You had to know that. And let's just check to see if it looks perpendicular to y equals negative 1/2 x plus 4. I was supposed to be perpendicular to y equals negative 1/2 x plus 4. Remember that perpendicular lines are not going to look perfectly perpendicular. But that looks correct to me. That's how perpendicular lines look in your calculator screen. It looks a little bit slanted, but this is a right angle. Okay, so that's what you can expect, a little taste of what you can expect tomorrow. Are y'all going to be ready for that? You don't have a choice. This is true. Okay, now, the homework that was due yesterday, it was assigned Tuesday, and I wasn't here to grade it with you. But fear not, we shall grade it now. Here are the answers. Get your paper out and check it. And then if you don't understand something, plus I did this answer key really quickly, guys, so I could have made a mistake. So if you don't agree with me, you should always ask a question. And anything from this sheet could be on your quiz tomorrow, including number 5 and 6. Those were the trickiest ones. And 9 and 10, I gave you a picture instead of actually telling you the line. JJ, what are you singing? What are you singing? You heard what I said. Alright, these are 10 points each. Zoe? Number 2. Okay, number 2 looked like this. I gave you a point to use. I told you this point had to be on the line, positive 1, negative 4. And I told you to be perpendicular to... Oh, you just wrote the question wrong? Okay. Never mind then. Anything else? Number 10. Number 10 was one of the ones that was a picture. Okay, can I switch screens so I can look at what number 10 looked like? Has everybody done grading? Switching screens. Switching screens. Okay, number 10. Here's what number 10 looked like. First of all, I didn't tell you the line to be perpendicular to. I gave you a picture of it. So I need to figure out the slope of this line so that I can know how to be perpendicular to it. Let's count out this slope. It looks like it's definitely a positive slope. It's pretty steep. It's going up 3 over 1. Up 3 over 1. So this line has a slope of 3. So what should my slope be then? Negative 1/3. You have to do two things on perpendicular lines. You have to change the sign and you have to flip it upside down. So now I have my point and I have my slope. The only thing I'm missing is my b. So y, which is 8, equals m, which is negative 1/3, times x, which is negative 9 over 1, plus b. Y equals m times x plus b. Now, I did make something nice happen on all these. The fraction disappeared on these, I think. I thought all of them. No? Negative 1/3 times negative 9. If you don't like multiplying fractions, then by all means use your calculator. First of all, I know that's going to be positive. Positive 9 over 3, which is 3. And then just subtract 3 from both sides. 8 minus 3 is 5. So my answer should be y equals negative 1/3 x plus 5. I'm going to graph that on the picture just to see if it looks right. It was supposed to be perpendicular to the line I gave you. I said the answer is negative 1/3 x plus 5. I'm going to put a dot at 5, and I'm going to go down 1 over 3, down 1 over 3, or up 1, backwards 3, up 1, backwards 3. Do those look perpendicular? Yeah, they do to me. Okay, don't make fun of my line. And then negative 9, 8, unfortunately it's off the graph, but negative 9, 8 would be on this line. Alright, anything else on the homework? Yes. Number 8. Okay, number 8, I gave you a line to be perpendicular to and a point. And I was nice on number 8. I had the line already in slope-intercept form. So what is the slope of this line I told you to be perpendicular to? Well, this slope is 2/3. So my slope, if I want to be perpendicular, better be negative 3 over 2. That's correct. Okay, so that's the slope I'm supposed to use, and I'm supposed to use the point negative 4, 6. So y, which is 6, equals m, which is negative 3 over 2, times x, which is negative 4, which looks like negative 4 over 1, plus b. So 6 equals, this is going to be positive 12 over 2, which is also 6. What's my b value here? 0. This is crossing the y-axis at the origin at 0. So y equals negative 3 over 2x plus 0. And I just wrote it like y equals negative 3 over 2x. I didn't put the plus 0. So you don't have to. Alright, y'all are okay with 5 and 6? Why were 5 and 6 trickier? Because I gave you the line to be perpendicular to. I gave it to you in standard form. You had to do some work first before you could find the slope. Alright, are we okay with this homework? Pass that up. Get your notes out. We're going to have quite a bit of time to work on homework because I'm going to pass back the inequality worksheet from yesterday. Oh, you guys kept it? Okay, some periods they turned it in. We'll go over it. Don't pass that up yet. Just keep the inequality, but pass up the perpendicular line stuff. I want to make sure you know what you're doing on that, so just hold on to it. Okay, let's talk about that inequality worksheet real quick then, if you've already got it out. Somebody hand me theirs real quick, because I want to see it. Yes. So, the homework that the sub was supposed to give you yesterday, remember it looked like this? I think somebody turned it in. I've got 1 or 2 papers. If you turned it in, I'll give it back to you. Yeah, if you wrote it on another sheet of paper, that's fine. Let's look at what number 1 looks like, and I want to make sure you understand what you're doing here. Okay, so number 1 on your worksheet had a y-intercept of -1. And the point +4, -4 was on the graph, right? This one was dashed, and it was shaded in this region up here. So all you're doing is you are going to write what inequality is pictured. So you do have to know where the line is, and then you look at the shading. Is this above or below the line? Above. Is it a solid or dashed line? So I know this is going to be y is greater than. It's just greater than because it's dashed. If it was solid, I would put greater than or equal to, but it's not solid. And I'm putting greater than because it's shaded above. Then all you got to do is figure out the slope and the y-intercept. The y-intercept is a -1, so I know there's going to be a -1. And the slope from here to here, keep in mind, some of you are messing up on the negative. This is definitely a negative slope. I've got to go down 1, 2, 3, and over 1, 2, 3, 4. Also, please don't forget to put the x in there. So your number 1 answer should look like this. Y is greater than -3/4 x minus 1. That's all you do. Look at the picture and write the inequality. Are there any other ones on here that you were... Yeah, number 4, if it's completely flat. I'm not going to do number 4, but let me do one similar to number 4 for you. Okay? Let's say I had this picture right here. This is completely flat, and I'm shading above. What's the slope of that line? What's the slope of this line? 0. What's the y-intercept of this line? 1. Okay, so if I was just looking at the line, this line is y equals 1. But I'm not just looking at the line, I'm also looking at every point that's above the line. Is that above or below? Above. So every point that's on the line or above it can be described by this. Y is greater than or equal to 1. Now, if this was dashed, no, it's not dashed. But if it were dashed, it would just be y is greater than 1. If it was shaded below, it would have been y is less than 1. Are you with me there? What if it's straight up and down? Let's do one that's straight up and down. Straight up and down lines are the outlaw lines. Let's just practice one like this. Okay, and I'm going to shade over here. Now I'm not talking about normal lines anymore. This is one of those outlaw lines. So if you just looked at the line, what would the equation of this line be if it were drawn in? This would be x equals 1. Are you with me there? This line is at x equals 1, but it's dashed. Look at all the x values over here. I'm shading to the left. Are these x values that I'm shading, are they getting bigger than 1 or smaller than 1? So the points that are shaded here have x values that are less than 1. And if this had been solid, it would have been x is less than or equal to 1. So that's what you're doing on your homework. You're just naming the inequality that is shown. No, that I'm going to let you, that's part of your assignment tonight. If you didn't finish it or didn't understand it, then you can finish that tonight. Okay? That's not the only homework for today. Okay, let's get to today's lesson, which is fairly simple. I think you're going to like it. It's not bad. Okay, the homework or the assignment for today, we're talking about intercepts, which you already know a lot of this stuff. And the calculator can help you do this assignment. Intercepts. And we're talking about linear intercepts. Okay, we've already done intercepts with quadratic equations, I mean. Now we're looking at lines. And the lines that we're going to do today, there's all kinds of ways we can give you the equation of a line. So far we've talked about slope, intercept, and standard form. Today we're just going to look at lines that are already in slope, intercept form. So it's already in slope, intercept form, which means one of your intercepts is going to be super easy to find. Let's talk about the easy one first, y-intercepts. Y-intercepts, the y-intercept of any graph, whether it's linear, quadratic, exponential, whatever kind of function, what does the y-intercept mean? It's where it crosses the y-axis. Where it crosses or touches or intersects, where it crosses the y-axis. So if I tell you a y-intercept, I am also telling you a point. Every point that's on the y-axis has something in common. It has 0 somewhere. Where? In the x position. This happens when the x value is 0. Think about it. If you think about any point that's on the y-axis, like let me just say, here's a y-intercept right there. Do you agree that's on the y-axis? What point is that? That point right here is at 0, 3. So the y-intercept always has an x value of 0. Always, always, always. Any y-intercept on any kind of graph. So, for example, if I tell you I'm thinking of a graph that's got a y-intercept of -4, you should know what point that is. What point is that? 0, -4. That's something that you got to know about intercepts. So everybody should be writing this down. I see some of you gazing off into space, looking at your calculators, putting on makeup, playing with your nails. Okay, that's y-intercepts. X-intercepts, which we have done a whole bunch of work with x-intercepts when we did quadratic functions. What's another word for x-intercepts? The zeros. What else? The roots. Now usually we talk about zeros and roots when we're talking about quadratic functions, but you can find the zero of a line as well, or the zero of a exponential function. It's just the same thing. It's when the function crosses the what? It's where it crosses the x-axis. That's why it's called an x-intercept. Where it crosses the x-axis. When does that happen? When the y value is a 0. So, for example, if I told you I'm thinking of some kind of function that's got an x-intercept of 2, automatically you should know that point. What point am I telling you is on this graph? 2, 0. You have to know that an x-intercept happens when the y value is a 0. Okay, now this part you don't have to write down, but I just want you to keep this in mind because they love giving you real-life problems about lines or parabolas. Do you remember we did a problem about a kid driving home from some far distance, and it was doing this? This was distance from home. Let me just tell you, in general, it's not always, but in general, the y-intercept of a function is usually where something starts. So this was his distance from home when he started. The x-intercept is usually where it ended. This is when he did what? When he got home. Okay, so let's say we were talking about, I've seen problems about a bathtub draining or a tank draining, something draining. What do you think the y-intercept would stand for if you're talking about something that's draining? Yeah, this is the amount of water or oil or whatever you started with. Water? Oh my gosh. Now y'all are making fun of my speech. Now, the x-intercept, when the water is done draining, what would the what would this be? When the tank or the tub or whatever is Empty. That's when it's done draining. The liquid that is in the contraption is done draining. Okay, I also saw a question one time about a bird feeder. Birds were eating from a bird feeder at a constant rate. What do you think the y-intercept would be? How much bird seed you started with? What's the x-intercept going to be? When the bird seed is gone, when it's empty. On the rocket problems, the y-intercept usually was where the rocket was launched, like a 5-foot platform. What did this represent? When it landed, the time it took for it to land, the time it took for it to be over, the time it took until it's on the ground. So y-intercept is usually where it starts, x-intercept is usually where it ends. Just keep that in mind. Okay, let's do some math, shall we? This is easy, easy, easy. Your job on your homework tonight... Oh, he's awake. Trajan, you're awake, right? Okay, good. I saw a blink. Are my other Sleeping Beauties awake? Zoe's awake. Ramiro's awake. Idalia's not putting on makeup. Everybody's paying attention, right? You are going to label and tell me what the x-intercept and y-intercept are for these functions. And I told you they're going to be lines, and they're already going to be in slope-intercept form. So one of these is super, super easy. Actually, both of them are. Are you ready? All right, number one, here's a linear function. Y equals 2x minus 7. What's the y-intercept? -7. See how easy that was? And the x is not that hard either. Now, let me just go back and tell you about this y-intercept, folks. If it wasn't in slope-intercept form, I know that you know, hey, it's in slope-intercept form. That means I can see the intercept. But pretend like it's not. You can always do the math. Y-intercepts happen when the x value is a 0. So y would equal 2 times 0, which is 0, minus 7. And what's 0 minus 7? -7. Did I have to go through that when it's already in slope-intercept form? No. But that's going to help me find the x-intercept, because it's kind of the same process. If I want to find the x-intercept of any function, linear, quadratic, no matter what, where would I put the 0? For the y. The x-intercept is where the function itself equals 0, where the y value is a 0. So you just plug in a 0 for y, and then you got a little bit of math to do. Something's got to move over to the other side. You can either move the -7 or the 2x. All right, let's add 7 to both sides. Then what? Divide by 2. What's the x-intercept? 7 over 2. That's pretty much the whole lesson. Not quite done with you. I just want to make sure you understand it. Now, here, I'm not going to make you do. This is what your homework answers should look like. X-intercept labeled, y-intercept labeled. Are we good with that? What if I required you to write it as a point, though? What point would the y-intercept of -7 be? 0, -7. What point would the x-intercept of 7 over 2 be? Okay, so I'm not going to make you do that, but I want to make sure you understand that. Here's the other thing. I kind of hesitate to show you this because I want you to do it both ways. Some of the exams that you're going to take, folks, are part calculator, part brain, part pencil and paper. So if you are required to do this with pencil and paper, I absolutely want you to know how to do this process. But we could also do this in the calculator. We did it with quadratic functions, remember? Yeah, you just want to put in the function rule. Finding an x-intercept is just the same thing as finding a 0 of the function. X-intercepts are when the function equals 0. So I'm going to put in the function y equals 2x minus 7. What else would I put in? Y equals 0. That's what an x-intercept is when the y value is 0. And then I would see where they do what? Intersect. Okay, now that's my x-intercept right there. I already got the answer as 7 over 2. First curve, second curve, guess. Look to see what my calculator tells me. What does it tell me? 3.5. Guess what 3.5 is? 7 over 2. I want fractions. So if you're going to use your calculator, I'm going to at least make you change that to a fraction. This is what I would suggest. I would suggest you do it this way and then check it. Well, it can get more difficult when the slope is a fraction. Let's do one where the slope is a fraction. Number 2. It's not that bad though, folks. Y equals 1/2 x minus 3. And I told you these are all going to be in slope-intercept form. Tomorrow they won't be, or Monday whenever we do the next lesson. What's the y-intercept here? -3. That part's easy. But again, what's really happening is I'm putting a 0 in for x. 0 times 1/2 is just 0, and I get 0 minus 3, which is -3. That's what's happening. But do I have to do that work? Not when it's in slope-intercept form. If the y-intercept is a fraction, then it's just a fraction. Now, the x-intercept. Let's talk about how to do this mathematically, because I absolutely need for you to know how to do it mathematically. X-intercepts happen when the y value is a 0. And we've got a fraction in our equation. No problem. How can you get rid of that fraction? Double everything. What's 2 times 0? Still 0. What's 2 times 1/2 x? Just 1x. What's 2 times -3? See how easy this is? Now what? Move the -6 to the other side. Add 6 to both sides. What's the x-intercept here? 6. Okay, so x-intercept 6. Idalia, I don't think you are doing this problem. This is not optional, folks. Now, let's check it in the calculator. Y equals 1/2 x minus 3. 1/2 x minus 3. Finding an x-intercept means I'm finding a 0. I'm going to calculate where they intersect. I'm supposed to get a 6. Does it look like 6? It does. And it is. Okay, now, what if it doesn't show on your screen, you calculator people? You try these two, please. Number 3. Y equals 2x plus 5. I'll give you one with the whole number slope. And number 4, y equals -2/3 x plus 9. List the x and y intercept. And I would really strongly suggest you at least do some of the homework by hand. At least do 1 or 2 of whole number slopes and 1 or 2 of fraction slopes by hand. And then check it with your calculator. Well, I want you to know how to do both ways, but did you just say there's a calculator way? I just explained for 5 minutes how to do it the calculator way. JJ? Yeah, all that gum you've been chewing is... Sometimes, to me, sometimes it's just faster to do it with paper and pencil rather than having to stop and punch everything into the calculator. Anyway, now if it were a quiz or a test or some kind of major grade, I would absolutely do it both ways. I like you to have more than one method so you can be 100% sure you're doing it right. I'm not just saying that. See, this is why you can't always use your calculator. Sometimes you need your brain. There is a trick on number 4, isn't there? And don't forget, I want the fraction answer, you calculator people. Alright, number 3, the y-intercept was 5. The x-intercept, I'm just going to do it by hand. It doesn't take that long at all. I put a 0 in for y. I moved the 2x over and made it -2x. I just subtracted 2x from both sides. I got -5/2. And to me, that it goes super fast. It's faster than plugging it into the calculator. Now, would I check it if I were you? Absolutely. Y equals 2x plus 5. I'm finding the x-intercept now, so I'm going to calculate where they intersect. Oopsie. I did pause it. The calculator's trying to tell me to be patient. And I got negative 2.5, which negative 2.5 is the same thing as negative 5 over 2. So I know I did this one right. All right, the y-intercept of number 4 is just 9. The x-intercept, so if you went straight to the calculator and didn't listen to Ms. Himes' suggestion, negative 2/3 x plus 9, and you didn't change the screen or anything, and you did calculate intersection, what does it tell you? It said error or something, didn't it? Why does it say error? Yeah, your calculator will not show you will not tell you an intersection unless it can actually see where it's intersecting. And I can look at my line here. It's going to cross the x-axis somewhere way over here, somewhere way past 10. So I have a couple of choices. I could change my window. I'd have to make my x maximum bigger than 10, or I could just zoom out. Do you see how if you hit the zoom key, I could zoom out? You do have to press enter after you zoom out. The reason why I don't use zoom out that much is because it kind of distorts the picture. It's like looking at a map from like Google Maps from way away. But as long as I can see where it's crossing and then do it again, second function, calculate, intersection, first curve, second curve, guess. And I got 13.5. What did Miss Heim tell you she wanted the answer as? A fraction. So I'm going to at least make you change that to a fraction, which should be 27 over 2. Let's do it the math way. Put a 0 in for y. All I've got to do to get rid of that fraction is triple everything. Well, 3 times 0 is still 0. This would give me negative 2x plus 27. See how easy that was? Move the 2x over it, the negative 2x over, it becomes positive 2x, and x equals 27 over 2, which was 13.5. All right, so are we good with the homework? So the two things you should bring back to me tomorrow, page 313, 10 to 19. Please ignore the directions. All of those are in slope-intercept form. I think the directions might say something about graphing them. Don't even worry about graphing them. I want you to label and tell me the x and y intercepts. Make sure you label it and tell me both numbers. The other thing you need to bring back to me is that inequality worksheet that you were given yesterday that we talked about briefly. That's also due tomorrow. Some of you have already done it. Just check over it.